Hello, everybody. Let us now do the threshold autoregressive model. So, threshold autoregressive models are a class of nonlinear time series models where the behavior of the series changes depending on the value of the observed threshold variable. The key feature of TAR models is that they allow for different autoregressive processes in different regimes, with transitions between regimes determined by whether the threshold variable crosses a specified threshold value. We can see that here. So we go to views, we go to quick estimate equation, and we choose the threshold regression part. So here we write the dependent variable followed by the list of threshold varying regressors, and here we write the threshold non-varying regressors. First we will do the discrete tar, which is on the basis of an observed variable. The regimes are divided into discrete understandable regimes. There are distinct threshold regression happening, so we'll have distinct regimes in this case. Okay, so here you can give more than one variable also. However, the optimum threshold variable will be chosen by the software itself. It is not always the case that the variable that we are considering on the basis of which we want to form a threshold is the correct variable. There are a lot of cases in which the variable that we consider is not the correct variable for a threshold to be built, and eViews shows us the result in that way. So we should give the threshold variable in a careful manner. So here we are doing the Kpim beta check, that how is the Kpim beta in the case of volatile markets or in the case of positive market returns, and how is the Kpim beta in the case of not that good market returns, and the market returns will be our threshold variable. So we write here Sensex return, yes, and here we write the dependent variable first, and then we write the threshold varying regressor, which is the Sensex return. Okay, and we are doing a discrete tar. We were not putting any C of the constant term here because we are not considering the Jensen's alpha variable. We're not considering any alpha. If this is like an OLS, then we're just doing Ri equals to beta of Rm. Ri being the return of the IT sector and Rm being the return of the Sensex sector. So we are not considering any constant term here. So as we can see that Sensex return is not being accepted as a variable on the basis of which regime changes can be estimated. So they have just considered one regime, which is that's why. So let us consider then Sensex return minus one. Even here also, views is not considering that it is correct to do two different regimes on the basis of this variable. So we will take IT return and let's see. So the threshold here is IT return, and here we see the cap and beta, and we compare it how the cap and beta reacts in the case of good performance of the sector and in cases of bad performance of the sector. So when the sector return is very low, then the cap and beta is very high. However, the cap and beta decreases as in the case of moderate sector returns. And then the cap and beta again increases a little when the sector return is becomes much better, which is much more positive, as we can see from here. So beta in regime 1 is 0.908, beta in regime 2 is 0.16, in regime 3 is 0.64, and in the last regime it is 1.06. So beta is higher in pessimistic market. Sorry, beta is higher in the case of pessimistic sector returns, and beta is lower in the case of moderate sector returns. However, in the case of very high sector returns, we have higher beta, which shows that it is in a huge, in lot of cases, it is a panic driven stock. Now we can do a multiple threshold test to see that what is the optimum number of threshold variable. Okay, so like we can sorry, not threshold variable. So we will do the multiple threshold test to find out what is the optimum number of thresholds. So here they have given four thresholds, but we have to see, is this the optimum number of thresholds, right? So we have to check that. So to do that, we will do the multiple threshold test to see whether four like regimes, whether it is correct or not. Four regimes means three threshold period. First is this one, then this one, then this one. So like if we have three threshold periods, and on the basis of that four regimes are there, so is it correct? So like I would show it through a graph also. Like, so suppose this is the data set. So if we have one, two, and three regimes, then we actually have, sorry, if we have three thresholds, we have four regimes. So we have one, two, and three thresholds, and we have one, two, three, and four regimes. And suppose if we had like one threshold, one particular threshold, then we would have two regimes. So it shows like what should be the optimal number of thresholds. So the threshold variable is IT return, that has always already been chosen by EVUs, because on the basis of Sensex return we were not getting any different distinct regimes. So to do it, we would do the multiple threshold test. Okay, yeah. So yeah, so we do the test, the F test here. So 0 versus 1, it is significant at 0.05% level. So we see that so it's not true that there are zero thresholds. There are at least one threshold. Then we do 1 versus 2. Then we see that it's not true that there is just one threshold. There is more than one threshold. So at least two threshold. Then the test is 2 versus 3. So we see that there are not just two thresholds, but more than two thresholds. That is, at least we have three thresholds. And 3 versus 4 is not significant, which means that we have to conclude that there are three thresholds. And three thresholds means four regimes, as we saw. So the our analysis was correct. Okay. So the biparo test tells us the optimal number of thresholds, as we saw. Now we would go to view model selection summary, and we would look at the criteria table. Yeah. So it does show that number of regimes is 4, as was shown in our analysis. Now we should check the SSR also. Like SSR here is 0.224, which is not very high. It is low. However, we should keep it in mind, and we should continue our checking on the basis of other threshold variables also. And then we would see the SSR and see the SSR is lowest in the case of which threshold variable. So let's take IT return minus 1. Sorry. So IT return minus 1 is also not being accepted as a threshold variable. So we would continue with IT return. And as we saw, that the SSR was not very high. Sorry. SSR is 0.2242, which is not very high. So here we end our analysis on the basis of TAR, that is threshold autoregressive model. In the next video, we will do VAR, that is vector autoregressive model, and we would construct the spillover index also. Thank you so much for watching.